Now that you're able to perform operations between functions, now we need to take two functions and put them together. We call that doing composing or a composite function. It's one function that's made up of two other functions. But before we get to that, we want to make sure we can evaluate composite functions. So in other words, we want to make sure we can take a number, put it into one function, and after we get that result, put that result into a second function. So let's start with these first two examples, which are review. Just reviewing what function notation looks like. So I'm asked here to find f of 2. What does that mean? Well, that means go to my function f, okay, I'm there, and now every time I see an x value, I'm going to substitute 2 in for that x value. And then I'm just going to use order of operations. So 3 times 2 is 6 plus 4 is 10. So I get f of 2 is equal to 10. One mistake I see students make a lot is they want to try to divide by 2 to in some way solve for f. This is not asking me to solve for f. This is telling me f of 2 means with my given function, when x is 2, y is 10. So this is my final answer here. Looking at the second one, it's the exact same thing. It's telling me to find g of negative 3. It's not asking me to solve for anything. It's asking me to find or evaluate. So I'm going to go to my function g. Okay, I'm there. Now I'm going to put a negative 3 in for every x value I find. I always substitute in with parentheses, which does make a big difference as we've looked at this year when we square here. So remember, this means negative 3 times negative 3, which is positive 9, times 2 is 18, plus 9 plus 1, so I get g of negative 3 equals, after I add those together, 28. Again, this isn't a variable I'm trying to solve for. G stands for my actual function. So now we need to look at this new notation. It looks like, and it kind of came across here, but g, it's read g of f of x. It looks like GOF. It also oftentimes you'll see it written as FOG. Students often refer to it as fog and say, what does fog mean? All these composite functions mean g following f of x is how that's read, or g of f of x is the same thing as saying this. And we will always, according to order of operations, start in our innermost parentheses with f of x. As I said in the beginning of this video, we'll evaluate that, and then we'll put that result in for g. Again, the other one that you're going to often see is f following g of x, which stands for f of g of x. And again, we'll start with our innermost parentheses here, get a result, and plug it in for f. So let's go ahead and look. I have 3 examples. Many of them do have a part A and a part B. On number 1, I'm asked to find g following f of 2. So I'm going to go ahead and do that. So the very first thing I do when I see g following f of 2 is I rewrite it with parentheses, because to me that makes it easier to follow order of operations. So order of operations tell me to first find f of 2. Well, as we saw up above, that means take 2 and put it in for f. Well, since f is x cubed, I'm going to put 2 in for the x, and I'm going to now have g of 2 cubed. Well, with math, we always do anything we can. I know 2 cubed is 8, so that's going to give me g of 8. And what does that mean? Well, as we saw up above, that means go to my function g and now plug 8 in for my x. So when I do that, I'm going to end up with 8 squared plus 7. Well, 64 plus 7 gives me 71. So this is my value. Oftentimes in math books, you will see that they will set f up like it's a machine, and they will set g up like it's a machine, and they will first show 2 going into f, coming out of this machine as 8, and then 8 going into the g machine and coming out as 71 to kind of represent that what am I doing? I'm putting that value into one function and then putting the result into another function. So that was kind of part A here. Part B, I'm going to now find g of f of negative 1. So notice that my inside I changed values, so I have g of f of negative 1. So g of f of negative 1 is going to be g of, what does f of negative 1 mean? It means go to my function f, okay, I'm there, and now put -1 in for every x value. Okay, well that means I now have -1 cubed. I can do this math. -1 times -1 times -1 is still -1. So now I'm left with g of -1. So what does that mean? Well, that means now I'm going to go to my function g and plug -1 in for every single x value. So I'll have -1 squared plus 7. Well, -1 times -1 is 1 plus 7 gives me a value of 8. Again, I get 8 after going to one function and then going to a second function. On example 2, I'm going to use the same f of x and g of x. And now I'm going to, instead of finding g of f, now I'm finding f of g. So f following g of -1. So again, the first thing I'm going to do is rewrite that with the little circle there replaced with a parenthesis, because then I can understand this as an order of operations problem. So notice it's taking the opposite function first as we did just up above. So now I'm going to go to g first, and I'm going to plug in -1. So I'm going to have f of, here's my g function, so I'm going to put -1 in for every x value. I always plug in with parentheses so I don't have any errors with my order of operations. Well, -1 squared is 1 plus 7 is 8. Well, now what does this mean? This means go to my function f and plug 8 in. Well, my function f is x cubed, so when I plug 8 in for x, 8 cubed ends up being 512, and that's going to be my answer after going into both functions. And there is, I believe, one more example with both a part A and a part B, so let's go ahead and look at this example 3. Again, I'm given two separate functions. I'm going to start with part A that tells me to do f of g of 4. Also, I didn't mention this, but since this is the last example, this would be a great one for you to try on your own. So now this gives me f of g of 4. What does that mean? Well, that means start on the inside, which tells me to go to g and plug 4 in. So I'm going to end up plugging 4 in here and plugging 4 in here. So I'm going to have f of 4 squared minus 2 times 4 plus 3. Using order of operations, that's going to give me 16 minus 8 plus 3, which is 11. So now what is this telling me to do? This is telling me to now go to my function f and plug 11 in. So I'm going to plug an 11 in for this x here, so I'll have 3 times 11 minus 7. Well, that gives me 33 minus 7, which gives me 26 as my final answer. So again, what did I do? I put 4 into g, got an answer, got a result, and then put that result into f. So part B is going to ask me to go in the opposite order. So now I'm going to start again by rewriting with parentheses. And now I can clearly see that order of operations tells me to start by this time putting 4 into f. Okay, well here's my f. So that's going to give me g of, I put 4 in for the x, so 3 times 4 minus 7. Well, 3 times 4 is 12, minus 7 is 5, so now I have g of 5. So what does that mean? Well, that means go to my function g, okay, I'm there, and I'm going to put a 5 in for every x value. So again, for this first x value and this second one, everything else stays the same, giving me 5 squared minus 2 times 5 plus 3. Order of operations tells me 25 minus 10 plus 3, and then 25 minus 10 plus 3 gives me 18 for my final answer. So to evaluate a composite function, remember you're plugging in for each function individually. So the inside function is always going to be the one that I plug in for first. After this video, please make sure you do go to that Unit 8 question sheet and answer your next question. There also is a book assignment that goes with this that you can find on gilpinschool.net.